And welcome back. In the last lesson, I asked you to make a simple calculator which asks for two numbers and then asks whether you would like to add, multiply, subtract, or divide them. So it went something like this. We would give it a number, then we would type in anything for yes, no would just be a enter, and then it would tell us the addition, the division, and whatever we asked for. And if we pressed enter on that particular operation, it would say you didn't ask for subtraction. So here's what my code looks like. Let me switch to side by side. Okay, so here's what my code looks like. First is just a simple print statement saying the name of the program, then an empty line because I wanted there to be some space between the two. Then I ask for the number, and then I immediately convert it to an integer. As you can see here, I don't use two variables, I just convert it immediately to an integer using the int function and put the input inside the parentheses. Same thing with the second number. I added another print statement here as well, just so there would be some space. Then I printed out these two statements outlining how the user needs to enter the numbers or select the operation. Another empty print statement with nothing inside. Then the add would contain the Boolean value of the input. Once again, I went straight to converting from input to Boolean. So I didn't have to make two variables. I went straight from input to Boolean. Did the same for all four of them. Just asked if they wanted to perform a certain operation and then stored the response as a Boolean in a variable. And then after that, it's a simple if else. I have four if else. Each one's saying the addition if addition was true. Otherwise, if it was false, then just say you didn't ask for addition. And it does this for addition, subtraction, multiplication, division, and that's it. And that's how I did mine. Your code should look similar to this. You could have used a couple more variables, but that's fine. But as long as you got the program to do what we wanted, that's okay. So let's move on to the lesson now. In today's lesson, we will learn how to make conditions in conditional statements more complex using comparison and logic operators. Let's have a look at comparison operators first. With comparison operators, you can compare values with each other and get a Boolean as a result of the comparison. To check if the values are equal, we write two equal signs between the two values. This will return a Boolean value, so either true or false, depending on whether the statement is correct or not. Keep in mind that the position of two values can be switched around here, since checking if value 1 is equal to value 2 is the same as checking if value 2 is equal to value 1. To check if two values are not equal, we write an exclamation mark with an equal sign. This will also return a Boolean, either true or false depending on whether the statement is correct or not. The values can be switched around here as well. We can also compare if one value is greater compared to another value. We do so by writing an angle bracket between the two values. The angle bracket always opens up towards the value that you think is bigger. When it opens up to the left, it is also known as the greater than symbol. One thing of importance here is that the values cannot be switched around. If you want to switch the values around, you have to also switch the operator. You now need to check if value 2 is less than value 1. It is denoted by the less than symbol. The less than symbol is the angle bracket that opens to the right. So, both the green operators will return the same Boolean value if you switch the operator while switching the values as well. We can say the same about the operators in red. The less than or equal operator and the greater than or equal operator need to be switched if the values being compared are switched. Which means if value 1 is less than or equal to value 2, then value 2 is greater than or equal to value 1. We add an equal sign after the angle bracket here to denote equality as well. Keep in mind that the equal sign always goes after the angle bracket. Since comparing values returns a Boolean value, we can use them with conditional statements. We can also do multiple comparisons using logic comparators. Let's have a look at them now. Logic operators compare Boolean values and return a Boolean value as well. We will go over three logic operators. The first one we already looked at when we introduced Boolean. It is the not operator. It takes one Boolean value and simply returns the opposite of that value. It returns false if the value is true and returns true if the value is false. Another operator is the AND operator. It takes two Boolean values and returns true only if both Boolean values are true. The OR operator takes two Boolean values as well and returns true if either one or both values are true. I have added a logic table to show the result of different operators with different Boolean values. Let's try coding these operators now. So we can start by typing in print and just comparing if 2 is equal to 2. We can actually just write that here. As you can see, it says that it is true. We can try comparing 2 to 3. Now that's definitely false because 2 does not equal 3. But we can check if 2 does not equal 3. That should be true. And it is. We can compare if 2 is less than 3. Now that is obviously true. We can do it the other way around, which should give us false. And it does. We can check if 2 is bigger than 2, which should be false. But if I add an equal sign here, it should now say true. We can do the same with strings as well. We can say is hello equal to hello, and it's obviously it is. But if we remove 1 from there, that's false because hello does not equal hell. Then we can compare. Let's try comparing a string to an integer. Let's see what happens. Now this is a unique one. If you try to compare strings with anything else, it's going to say false because it's going to check that one type is not equal to the other type. So immediately it's going to tell you that that's false, that they can't be equal because one is a string, the other one's an integer. So that's something to look out for. Also, we can compare strings if one let me just copy this right here. So we can compare if hello is bigger than hell. It checks which one would appear first in a dictionary. So hell would appear before hello, so that means it is true. This should print out true, and it does. We can also compare other strings, for example this. Now numbers, for example, are supposed to come before the alphabets. If something has a number, then it will come before something with a letter. So this should also be true, and it is. We can try comparing this will not work because it's, even though it can check whether hello is equal to 10, it cannot check if hello is bigger than 10 because at this point it needs to have the same type. So here it's like, okay, it's not the same type, so they're not the same. But for this to work, it has to have the same type for it to check whether one's bigger than the other. So it's not going to give you anything. Let's use variables now. Let's assign x to 2, and we can just do whatever we just did with them. We can do it here as well. This should print true because x is 2. Did I run it? Yes, there you go. Then we can also use the operator, the logic operator, not x equals 2. This should print false. There you go. This is a double negation. This should print true, and it does. Now we can have another variable, let's say y equals 2, and we can have print x equals 2 and y equals 3. Now it's going to check if x is 2 and it's going to check if y is 3. And it's false because y is not equal to 3. For this to return true, both these conditions should be true. But if we change 2 to 3, this works because now y is 3 and x is 2. We can change this to an OR. We can change y back to a 2, and this now should print true because only one of the conditions needs to be true for this to print true. If both are false, then it's going to print false, as it does right now. Now let's see what we can do with using conditional statements. So instead of this, we can just type in if x is 2 and y is 3, we can change this to an and then we can say print x is 2 and y is 3, right? Now we can add another elif checking. So this elif will only be executed if this is false. That means either one of them is false or they're both false. So now we'll check for one of them, right? We'll say elif x is equal to 2, then we can be sure that x is 2 but y is not 3, right? So now this will only run if this is false, and if this is false but this is true, that means y has to be not 3. That's what we print here. We can have another else that prints out y is 3. Now this means when we reach the else, that means this is false and this is false. So either y is not 3, or we can add another elif actually, just to be sure. We can say elif check if y is 3. Else y is not 3 and x is not 2. So these are the 4 conditions that can be. Either they can be 2 and y can be 3. It would print out x is 2 and 3. Then it's going to check, okay, so this is not true. Let me check if x is 2, if the first condition is at least true. It checks that. It's like, okay, if the first condition is true, that means the second condition must be false. So it prints this out. Then it's like, okay, this is not true either, then I need to check the second condition. The second condition might be true. It checks that. If it is, then it's like, okay, the second condition is true. It was the first one that was false, and that's why this was false. But it's like, okay, this isn't true either, then it must be that they're both false. So x is not 3 and y is not 2. So right now, it should print out this value, right? Because y is not 3 and x is not 2. And it does. Let's say if we change x to 3, it should, no, it's checking for 2. So if x is 2 and y is 2, it says x is 2 but y is not 3. And if we change this to 3, it should now print out x is 2 and y is 3, the first one, which is only true when both of these conditions are met. So that's for this coding lesson. Let's move on to the problem now. So for the problem for this lesson, we're going to improve on the calculator we made in the last lesson. So it's the same thing. It's going to ask you for a number first, let's say 12, but this time as soon as you enter the first number, it will tell you whether that number is odd or even. I'll show you how to figure out whether a number is odd or even after we go through the example. Let's say I put in the second example as 13 because I want to put in an odd number just to show you that if it is odd, it will say 13 is odd. Now before we had to either press enter for no or press in anything else for yes. This time around we're going to switch things to make them a little more, simpler. The user has to enter either yes, yes, or a y, or the user can enter no, no, no in these 3 forms. So if I say no, if I say yes here, and if I say n here, but for the last one, let's just say I don't follow the rules. I just press this. Let's see what happens. The first one, it checks like, okay, no. So you didn't ask for it. So as long as it's one of these, it will not print out anything. It will just say you did not ask for addition. For subtraction, if it's one of these, it's going to be like, okay, sure, I'll give you that. And then once you say n again, capital N, which is part of these, it's going to say, okay, you didn't ask for multiplication. Now, if I enter anything apart from these 6 values, like something like this, it's going to say incorrect input for division. So you're going to have to use elif as well in this one. And for this one, for the even and odd, this is how I do it. The remainder for when you divide something, for example, let's say 2 divided by, let's take a bigger number, let's say 6 divided by 2. The remainder here is 0, right? So that's what you want to check for. We use the modulus operator, and the result of the modulus operator for division by 2. So take this number, divide it by 2 using the modulus operator, that should give you the remainder, and then the remainder should be 0 if it's even. So for example, if I say 2 modulus 2, 0, if that's true, I know it's even, because I can do that with any number, right? Once again, this is also true, because 10 divided by 2, the remainder is 0. So that's how I checked for odd and even. So you have to implement this after each number, and then make these changes as well. You have to edit out the print statement as well, from saying whatever it was saying before to this. You won't have to convert this string to a boolean. You can just compare these values here to the values given in the choices, and if these do not match with that, then you just print out that the input was incorrect for whichever operation they asked for. So see if you can figure this out. I'll show you my solution in the next lesson, and I'll see you then.